So yeah, one important thing, we were looking at this complex.cc. All right. So, like there is this function signature that we are seeing on line number 32, and we can have an alternate function signature like this. So both these functions, with both these function signatures, with both these function signatures, it really works. Do you see the difference? So on line number 32, we are passing the parameter by call by value. Call by value, we are passing the parameter. And here we are passing it by call by reference. I forgot my writing pad, so yeah, so call by reference. The second line number 33, we are having call by reference. My mind got defocused, so I didn't bring my writing pad, so I cannot write. I will talk more today. So what is the advantage of 33 versus 32? Line number 32 versus 33? Yeah. So we don't make a copy. When we do a call by, yeah, excellent, Ayan. Good, Bhargav. So on line number 32, when we are passing the parameter using call by value, then we are copying the parameter. We make a copy. Copy happens. But whereas, so this is A. So there are two things here. One is copy happens. Second here is, here there is no copy. Number one. Number two, values, since it's a copy, values are not reflected. Values, modifications, mutations, mutation not reflected. Mutation means change in the state, not reflected in the original object. Okay, so here mutation reflected. That is, any changes, they are reflected in the original object, in the original object. All right. So, but if you see the way we are going to access, like the members of the parameter C, they are the same, whether it is call by value or call by reference, it is the same. On the flip side, if we have like something like this, if the parameter type is like this, then so here what is happening is we are passing the address of the object. We are passing the address of the object. Okay. This is still call by value. This is still call by value. This is still call by value, but we are passing the address of the object. So in this case, if you want to access the corresponding member, like for example, the member function or member method get imaginary, then we have to use this. This is the way to access the member function. Do you see the difference between line 32, 33 and 34? If you pass an address, then what happens is when we want to access the members of that object, we have to use the arrow operator. So this is pointer. This is, we are passing a pointer, and we are passing the pointer as a call by value. In the second, on line number 33, we are passing call by value, but it's not a pointer. On line number 34, it is call by reference. All good here? Do you see the difference? Very important difference. So when you see this thing, don't think it is a pointer. It's not pointer. We are just passing a regular object, but the way we are, but the parameter passing mechanism is called as a call by reference parameter passing mechanism. Underneath, the compiler may use the address of the parameter being passed to carry out the computations. Okay, but the way we are going to access the member functions is just on the way we are doing it on line number 36. So this is one idea. The second idea here is, here we are using c.getReal, c.getImaginary in order to access the real and imaginary parts of the complex number C. So you can see that the code is perhaps little bit not clumsy, but you have to type in a lot of code. So we can use, we can say that the method on line number 35 is a friend of the class complex. So this is the complex class. Remember, so this is our complex class. In this class, we are saying that, you know what, this method, this operator, that also works. Okay, in which case, yeah, because in the scope C, you do get real. I think, let's say, yeah. So, are you with me on line number 30? That we have declared this operator as a friend. Once we declare this operator as a friend, yeah, his friend is a keyword. Once we declare this operator as a friend, then we can directly access the private members of the this class. Then the private members of the class we can access. Remember, R and I are private members of the class. Now I think we can use C.R and C.I. These are the private members. So that way, the kind of when we are in this particular case, the amount of code here in this method is small, so it really doesn't matter. But when you are writing big code, then having access to this is in this way, in this simpler way, is a good idea. Let's compile and see if this works or not. Yeah, see, it's working. So you declare this method as a friend. Remember, where is the friend? Yeah, this is, so this is the friend. Okay, we declared this as a friend by putting this this declaration on line number 30. Are you with me here? That how you can make a method a friend to a class? We are telling the class complex, you know what? This particular method is your friend. And since it is your friend, it can access the private members of the class. Like on line number 43, C.R, C.I, etc. Are you all okay? Good, doing all right? Okay. So now we will keep this aside. And now we will come to, we want to write linked list. So I wrote the code for this before. So let's see how it, I'll explain this code. Today morning only I wrote. So, so if you see here, focus on line number 21 to 22, we have defined a class called as list element. We have defined a class called as list element. And then there is one more class called as list. The list element class you can see here. So line number 30, we have defined a class list. This list represents the whole, captures the whole linked list. This list, the class that we are defining, starting from line number 30, it defines the whole linked list. Whereas the class list element, it defines each element in the linked list. A linked list is a collection of elements which are linked to each other, right? And if you focus here, it has two data types. There are three private members to this. One is name. So now you can see that in C++, there's a class data type called as a string, and we can just use string data type. Okay, string is a class, and we are in name is an object of type class string. Are you with me on line number 17? It makes our life easier when we are working with strings. Name is an object of type class string. That's what we have on line number 17. And string is defined in the namespace std. It is defined in the namespace std. And there is a second data, that is age. And on line number 19, that is on 19, we have a pointer which points to the next element in the linked list. And all these three data items, they are hidden from the rest of the world. No one can access these data fields. No one can access these data fields separately. Are you with me here? What are the fields of the list element? Yes, no? Doing all right so far? Great. So now let's see. So now I want you to observe this constructor. We have a new constructor here, and constructors are there in the private. They are public members. Okay, so you can see that there is a method declared whose name is list element. Since the name of the method matches the name of the class name, it is what is called as a constructor. This particular constructor, it takes three parameters as input. One is name, another is age, another is a pointer to a list element. And if there is no pointer passed, then this pointer is set to null pointer by default. Okay, this is the default pointer. And you can see, so this is, there is a colon here, followed by that colon, we have what is called as an initialization list. So usually what we will end up doing it is, we say name, which is a member of this, which is a member of this class, we would like it to be initialized to like this, name underscore age is equal to, sorry, this is what we would like to do. But C++ says, you know, if this is the standard thing that you are going to do, I have a shorthand way of writing this, conveying this to the compiler, that is, you have this initializer list. So in the initializer list, what is in the parentheses is the parameter, and what you have next to it is the field to which this should be copied to. Okay, so we don't need this. So this is done automatically by this initialization list. Okay, PTR will be copied to next, underscore age will be copied to age, and underscore name is copied to name. And then if you go here, like for example, on line number 67, we are declaring that E, that the variable E, it's an object, okay, and it is of type class list underscore element, and we are passing two parameters here. And then what happens? What will happen on line number 67 when we do that? which constructor will be invoked? The constructor on line number 8 will be invoked, and PTR is taken as a default parameter volume, null pointer. So a list element is created here. A list element is created here. Are you with me here? One node is created. One node in the linked list is created. And that node has 3 fields. What are the 3 fields? What are the 3 fields in the constructor? So the constructor part is, where is the constructor? So this is the constructor. It is like, what is a constructor? When a new object is created, then some kind of basic things, you want to dress up the baby and perhaps want to do some basic things. Before it, you can use that object before that object starts living in the world. Okay. So here, usually you give a name, perhaps some age or some kind of stuff you do, maybe paint or dress or whatever you do before that object is available in the world. So what happens is typically let me see, I'll show you a different code. So let's say a different way of doing this is, so there are 2-3 ways of doing it, but let's say this is the way. This is simple name, age is equal to underscore age, and yeah, and then we say next is equal to PTR. So this is how we do, and we don't have this initializer list. Does this make sense? Does this constructor make sense? So when we created the list element, we gave the name as Suresh and age as 30. 30 is not my age, and I was just randomly doing. So don't mean for anything from it. Okay, I should have changed it before the class started. Okay, so yeah, and then PTR is not PTR when we didn't pass it any PTR, but there is a default parameter, null pointer, and null pointer gets assigned to it. But if you pass some parameter as a third parameter, PTR will take that value and PTR will be assigned to next. Are you with me on the constructor? This part 9 to 14. But but unnecessary code, right? 11, 12, 13. So we think the C++ Bijan Stroustrup, who designed the programming language, he said, yeah, so if you are going to do this all the time, I have a shorthand notation for it. After this parameter list, put a colon, and you have what is called as an initializer list. So this gets copied, underscore name automatically gets copied to name, so on and so forth. Underscore age gets copied to age, PTR gets copied to next. The default value of PTR is null PTR, but if some other value is passed, that value is assigned to next. All good? Okay. Let's see who is there in the class. I'll bother someone. Okay. So now let's go ahead and yeah. And then, so we overloaded this operator, left shift operator, so that when we do a C out on it, we get the age, we get the output in this particular format. And we made this method a friend of list element method, list element class. This is the list element class from 5 to 31. We made this overloaded operator method, left shift operator method, a friend of this. That way, instead of using e.getName, we can directly use e.name. Similarly, instead of using e.getAge, then we are using e.age. If it is not a friend, we cannot access e.name or e.age. So I'll write here, since we are friends, since e and operator are friends. So if they are not friends, then it will be e.getName e dot. Again, are you with me here? If they are not friends. Okay, so this is what is happening. Friend should be before or after private. It worked Amoga, so it should be fine after private also. I think it can be in public or private. It may not make a difference. That thought also came to me, but it worked when I compiled and ran the code. It worked. So now, so for the time being, let's comment out the code from here to here, and let's say cout less than b. What gets printed if you run this code? G++, what is the name of the function? File linked list. Out I see. What did I do? I should see, beautiful, no? We just have we did cout less than e. I'm feeling a bit narcissistic by putting my name here. I will put Amoga instead. I don't ask Amoga Sage, I'll just put 17. Okay. I think this is one example where I should not even take any of your names in the program. Okay, guys. I think we will change it to here and Alice. Not for any good reason, Alice and Bob exists. Okay, are you fine with me? Let's get over these the age obstacles that we are getting through and free up our minds and focus on C++. Okay, so 79, line 79, all good? Okay, nice. Okay. Yeah, so now let's go to the list. This is the list. This is the class which holds the linked list. Let's look at the private. It's very interesting. If you see the private member of the linked list, it has only one variable and it's a pointer to a list element. And it's a pointer to a list element. And it has public methods. And let's look at the constructor. So the list has this constructor where when we create a list, you know, the head is initialized to null pointer. Does it make sense or not? Initializing the head to a null pointer when the list is created. Like for example, here on line number, let's, yeah, I don't even need this. So now when we do this, what happens? A object is created, okay, and the default constructor that gets invoked is the constructor on line number 43, and the variable head gets initialized to null pointer. All right. And then there is a method. So are you with me on the constructor part? That's what should happen. When a linked list is born, there is nothing there in the world. There is a head which points to a null pointer. Now the this list has three methods, member functions. One is called as an insert method. The other is search method. The other is print method. These are the three methods that are present. The insert method, it takes a name and age as parameters. And it creates, now see the new, we are not doing malloc now, we are doing new. We are doing new. And then we are calling create a new list element, create a new list element with these three parameters, name, age, and head. And after that, so here we are inserting this new list element at the beginning of the list. So because of that, head is pointing to E. Does this make sense? That head points to E. Because E, so there is this linked list here. Okay, so there is this the linked list. There is the previous linked list. It is there. So now when you have created a new element and the new element is present here, so head instead of pointing to the previous first element in the list, let's say the previous first element in the list is let's call it as PE followed by the rest of linked list. Since I don't have a writing pen, so I have to use rest of. Okay, this is the original linked list, PE followed by rest of linked list. And then we have E pointing to, now we are prepending E. So now E points to that. So head should contain the address of the object E. Yes or no? And what should E next be? It should be, what should E of next should be? During this process, what should E of next should be? E of next. E of next should be current head. And is that happening? Is E of next is getting initialized to current head? Yes or no? Yes, because if you look at the constructor for this, so here we are passing the head as the PTR, and what happens is E of next automatically gets initialized to head. Are you all with me here? Again, it's very subtle thing happening. So what automatically, whatever it is, E of next gets passed to head, which is because we are PTR contains head and E of next is equal to head. See how simply it is happening, how constructor is automatically setting things up for us. How many of you understood this so far? How many of you understood the insert operation? In the insert operation, we have to do two things. Number one, E of next is equal to head. This is the number one task. Task T1. Task 1. Task 2 is, what is task 2? Let's go here. Where is this? Task 2 is head should become, the new head is E. Task 2, new E is the new head. Make E the new head. Can I see a raise of hands? How many of you are with me on this so far on the insert function? Good. Nice. I want to know whether you are understanding or with me. Great. Thank you very much. Now, let's go to the print function. The print function is very simple. So, what is the print function? Amoka, you have a question, or you can type in if you have a question. Or is it raise of hand? Okay. So print function is very simple. For list pointer is equal to cursor. Cursor is starts with the head, and as long as cursor is not equal to null pointer, we keep going to next and next and next. Okay. And here you can see cout is less than. The way we are printing the current node is by doing a dereferencing. What is the type of star cursor? What is the type of cursor? Variable cursor. What is the type of the variable cursor? It's a pointer to list underscore element. Yes or no? And when we do dereferencing, then the type of this whole thing is just a list element. And because of that, the corresponding print operator, the overloaded function, will be invoked. This is yet another important thing that I would like you to understand. All right. And then it just printed. Now, if you want to do the search, the idea is very simple. You keep going through the linked list, and at every place, you compare that name with the name that you're searching for. Like cursor points to the list element, you get the element, you get the name. This gives the name that is present in that particular node. And what is the type of this one? Oh, we can use equal to equal to. So it looks like we can use equal to, but otherwise there is a compare method in the string class. So we use the compare method in the string class to compare whether the two names are equal or not. But perhaps the method suggested by Abhinav is more preferable. So I think this is what he's mentioning. Cursor right, Abhinav, this is what you mean. This looks better. And remember, can we return cursor here on line number 59? Can we return just cursor? We cannot return because cursor contains the address. But we want to, but when we return star cursor, what happens is the contents of that object, or we make a copy of that, and that copy is returned back. Okay. Make a copy and return the copy. Does this make sense? Line number 59. That is because we are using star cursor and the return type on line number 52, if you see, no. So we want to return, like for, no. So what happens, there's a very, I thought about it a bit. So there are two ways of thinking about it. List element, star, search, string name. So why can't we use this? Line 52. Yes or no? That's what is the question, Sarthak. Then, if we are right now doing object-oriented programming, we don't want to expose a node that is present in the linked list to the outside world. And that person who gets access to that, that exact node inside our linked list, he can change the next pointer or do any of those things without our knowledge. So we don't want to give that to him. So because of that, we don't want to do line number 52. We don't want to give a pointer to the actual node that is present in the memory. While theoretically line 52 is possible, from software architecture perspective, we don't want to do it. Are you with me here? Oh, okay. So you think when you do a star cursor, even the next will go? Good point. I see. Very good point, Abhinav. I missed it actually. Even then also we will end up exposing our linked list to the outside world. Then we should not be doing this. We should be doing, we should just return something else without those details. All of you understood the point raised by Abhinav and Sarthak. So it's a very valid point. I think we need to have an alternate way of yeah. So maybe, yeah. I see. Yeah, there are ways of doing it. Yeah, of course, there are ways of doing it. Or we can have just written the name and just have name and, that age separate and just. That is not a problem, Bharat, because I know if it is not present, you can. I think there are some bunch of questions. We can just return age of that name. So that is the key value stored. So one way of doing it is usually all these called as dictionary data structures. So you give the key, you give the value. So someone asks for a name and you give all the fields associated with it. Because strictly speaking, next is an internal detail, right? The end user should not be worried about next and all those things. Yes or no? I have one nice way of solving this problem though. No, if you make this one next, next private, they will not be able to access next. Yes or no? Unless they dissect the object, using, there's a way to dissect it also, but theoretically, unless the programmer is hell-bent on figuring out what is happening, he will not be able to access next. Does this make sense? Are you with me? What we are trying to do? So by doing this, we cover at least some basic ground, but if someone wants to really hack things, like for example, we are storing, instead of age, we are storing credit card information. Then you use next, next, and then You cannot directly access it, but you can access it by looking at the bit representation and be able to access the credit card name of the next person. Is it possible, right? You know that a class is represented as a sequence. Everything is represented as a sequence of bytes. You go to that memory and you can perhaps do it. Are you with me here? Happy, unhappy? There's line number 30 is good, no? Let me see if I can compile this code. Oh, okay. Super errors. Why search is check line 46. I think some other things are there. Bargo has some interesting suggestion. Search has some issue. What happened? Yeah, this is 52. Delete. Let's see. Now I have 3 errors. Line number 46. Checkered, na? Line number 46. So what is the error, Ryan? Let's see. In the search, we are using cursor get next, but get next is a private method. Okay. I see. We cannot use it in the list. Yeah. So we are trying to use get next, but get next is a. So there is a way to solve this problem. There is a way to solve this problem. Let's copy this code. Now I found something. I thought there is one particular idea which I thought is unnecessarily complex. Linked list. We can not sure about that. Advance. Okay. So one can use it without knowing the password. One cannot use it without knowing the password. Bhargav has interesting suggestions. No, good, all good discussions. Yeah, I understood, Bhargav. Nice. I'm thinking of one more idea also. But okay, for the time being, we will leave it like that. Is it okay? But good problem. Yeah, we need to have access to next. Otherwise, there are ways to get around this. Okay, let's go back here. I thought I had a beautiful idea, brilliant idea, but then it got watered down. We'll take encrypted password and decrypt, and yeah, all good. It's going up above my head also. Oh. So where is the what happened now? Why is it a still complaint? Oh, I am in linked list too. All right. But I changed it, right? Oh, okay, okay, got it, understood, understood. Super. Linker list. I'll make this one. Let's go back here. Control V, Control Shift I, save. Cool. Awesome. All plus and up and down. Now what will happen if I do that? Okay. Thank you. What is protected for the time being? Let's protect ourselves from protected. It makes it more complicated. It is useful in the context of inheritance and stuff. Anyway, so now we have all these things. So now let's change to this to Alice and Bob. Okay, so we created a list, and then we are inserting two names, Alice and Bob, and yeah, and then let's print them first. L.print. Let's see what happens. See, Alice, Bob. So since we are inserting at the beginning, so Bob is coming first in the list, followed by Alice. And then we are getting dummy -1 because if Hari is not present in the list, we are creating a new list element with this dummy -1. So that makes me return list element cursor get name cursor get age. Now null pointer, the next will be by default initializer to null pointer. Okay, are you happy now? Fix. Yeah. So what we are doing is what is called as a defensive programming. People, when we write programs, so we just write them, but then there are people who use these things to figure out, who is the next guy in the credit card list, go find their name, blah, and all those things. So this is defensive programming. So we want to build the right program, which is not only correct, we also see that it is not prone to attacks. Okay. All right then. So let's say if we have a name which is present. Okay. Cout less than L.search. Let's search for Bob. Nice. So this is how you can code linker list, and we are not happy with this linker list because all these fields, we want to build generic linker list. If someone wants to use your library of linker list, and he is working, these are not the fields that he is working with, then he has to write code again. Well, it's not really. You are getting number of lines of code might be more, Abhinav. So, but in terms of the thought process, we are building software architecture. Okay, we are building a very systematically. We want to go about, like for example, you see that we have defined an operator for printing, and then we have encapsulated the data so that others cannot modify it. So we are going about it in a very systematic fashion So if you are building a library, you want to build a library which is robust, tight, no, not prone to errors. If there are bugs, they are easily isolated. All those properties you want to have if you are building a software. Okay, so it is worth the effort, definitely worth the effort. We have to balance though, like there are some advanced features of C++, and if you use them, very few people know, and when they try to read your code, they will go nuts. Okay, so I was, so my wife works for a, she's a senior architect in a big company. I was talking with her about this today morning, and she told one of the things they do when people join the company is they have coding guidelines. These are the things you are supposed to use, you can use, and these are the things you should not use. And this is the style you should follow. And when you write a code and you want that code to be pushed to production, there will be there will be one guy who checks the correctness of the code. There is another guy who checks if the stylistic issues, that if you are using a very weird feature of C++, he says, this is not going to, this is not all right. You should do something else. It looks cool, but but it will cause difficulties in terms of readability and other challenges. So he may tell you to rewrite the code in a different way. So if like if you go to Google or Microsoft, if you go to washroom, like just like in malls, if you go to washroom, they will have all nonsense written on the washroom walls. So, but here in Google, Microsoft, big companies, they will say, remember not to give unnecessary friendship to methods or something like that. Like that, they have written all over different things. And so interesting ways, cartoons which will remind you of what to do and what not to do. So it is time is 3 o'clock. I have some code for which I wrote to introduce you to STL containers. What I will do is I will just share this code with you instead of discussing them in the class. Just a couple of C++ files. These are called as STL libraries, standard template libraries, which are very, very useful. Like for example, here, if you see, there is one problem where I asked you to find word frequency. If you are allowed to use standard template library, you define an object, an STL object like this, dictionary, which takes, which has which is parameterized in 2 ways. Using 2 types, one is string and int. So if you see word dict of, let's say you have seen 10 words in a file, then you just say dict of word is equal to 10, or plus dict of word, and plus dict of the, etc. like that you can. And so that's all. So your problem, one of the problems is super simple. Word frequency problem, yes or no? You would have struggled a bit on doing the word frequency, but if you use STL library, it's just a half an hour job. So since it's the last class, I don't want to push more stuff into your brain, but I will post these 2 codes for you, and I request you to watch these 2 codes. And STL is very, very important feature. If you want to do some, when you are solving a bigger problem, you don't want to waste your time on writing linked list, working with arrays, etc. And so if you use them, this will become, your job becomes easy. I remember in 2-3 big projects I worked on as a graduate student, lot of code I have written is just a linked list and all this stuff. inserting, deleting, etc. But that's for a bigger project. A lot of energy is wasted there. But I should have just used STL, and so that I could focus on. And then there are bugs in linked list. You would want to debug them, so waste of your time. Instead, you should focus on the main project and use the data structures provided by the STL library. So with this, I will stop my discussion here. So Sardak, in C++, you try to use C++ as much as you can. That's what I should say. Unless there is a learning that you have to do. Like for example, right now you have to use, you want to learn how linked lists work. So you should write code for linked lists. Otherwise, you can use STL, right? So apart from that, unless you see a learning value in it, you should try to use you can use STL or try to use C++ as much as you can. Some simple features, try to make simple classes, things like that. Start there, get used to it, see the errors and see how things pan out, and it will help you in the long run to become good engineers, good computer scientists. But don't worry, I mean,